Hello, mga ka-GG. Welcome back to our channel. And as per request again from our dearest student, we will have a new lesson. Hope you like it. Now we're going to discuss about divisibility theory in the integers. So, a short way to determine the divisibility of a given integer by a fixed divisor without performing the division can be done through examining the digits or its digits. However, there are divisibility tests for numbers to do that. In this lecture, we will talk about some concepts related to the divisibility theory. So bear with me. Well-ordering principle, any non-empty set of positive integer contains a smaller member. So first we have here the division algorithm. If A and B are any positive integer, then there are unique integer Q and R, such that A is equal to B times Q plus R, wherein R is greater than or equal to 0 but less than B. So take note with this portion here. B is greater than our R. So let's begin the lesson with an example. Example 1. 5 divisibility. 5 divides 9. So here's our first example. So what we're going to do here is a simple division to emphasize our A, the value of A, the value of B, the value of Q, and the value of R. So we have here 5 and 19 inside. So 19 divides 5, that is 3, and it makes 3 times 5, it makes 15, and subtract. We have 4. So take note, this is our quotient. This is our quotient. And this one is our this is what we call our remainder. Take note mga ka-GG. So our Q means quotient and our R is the remainder. Whereas our A and B are any positive integers. So take note for that. And we will now write it in the division algorithm way. So we have here 19 as our value of our A equals 5, which is the value of our B, 5, multiplied to 3, which is our Q, plus our remainder, which is 4. So this is our A, this is the B, and this one is our Q, and this one is our R. So take note with the values that we have. So in another case, in another cases, remember that our B, the value of our B is 5 and the value of our remainder is 4. So take note, our B is greater than R. And for another cases, if R is equal to 0. So there are also cases that R is equal to 0. In this case, in which R is equal to 0, let's have an example wherein R is equal to 0. A is equal to our B multiplied to Q. So it can also be written as B divides A. So for example, our A is 10 and our B is of 5. So let me have it here. Write it down. So still 5. 5 divides 10. So 10 divided 5 is 2, of course, and multiplied together, and our remainder is 0. Oops, sorry. And our remainder is 0. In this case, we're going to write it in this form, the division algorithm format. A is equal to BQ plus R, wherein our R is 0. So we have now 10 as the value of our A equals the value of our B is 5. Yes, it's 5. And the value of our Q, which the quotient that we have is 2. So that is 2. And the remainder is 0. So these are some example cases wherein R is 0. So still the same. This will be our A. This is the B. And this is the Q. And the R. So in this cases, we will write the B divides A. So in this case, we write it this way. So 5 divides 10. and that is for the division algorithm. So here are the examples that we have. So let b is equal to -7, a is equal to 1, -2, 61, and -59. So we're going to express the result in A is equal to BQ plus R. So we're going to find the division algorithm given that B is -7 and given that A will be 1, -2, and 61, and also -59. First example that we have is 1. So we just simply input the given that we have. So we input the given, the value of our A. The first value of our A is 1, and the value of our B is -7. Now we're looking for the quotient and the remainder. So what would be the quotient so that we come up with the value of A that is equal to 1? So that would be 0. Hmm, let's write it na lang. That would be 0. And for our remainder, of course, if 0 is the quotient, then probably the remainder would be 1, right? There you go, 1. And next example, we have -2 as the value of our A and -7 as value of our B. And for the quotient, what would be the value? That would be that would be 1. And what would be our remainder? If 1 multiplied to -7, that is -7. So what to be put in here must be, yes, it's 5. So when we add them together, it would result -2. Next, 61. 61 will be the A. The still, our B is -7. So the quotient must be what? The quotient must be, the quotient will be the quotient will be -8. The quotient we have is -8, and probably the remainder will be, and for the last one, we have -59 equals to -7. So the Q would be, the quotient would be, yes, it's 9. And if the quotient is 9, what would be our remainder? That would be, da-da-da-da, is it 4? So 9 times 7, that would be -63. -63 minus plus 4, that would be -59. So much for that, and this would be all for the examples. Now, let's have the theorem. A, if A and B and C are integers, A is not equal to 0, B is not equal to 0, and A divides B divides C, then A divides C. So let me show you how these things happen. Let's show it by example. So example, we have 3 divides 12 and 12 divides 24. So, then 3 divides 24, following the theorem that we have. So in our theorem, considering that uh, if A and B and C are integers, then our A must not be equal to 0 and our B must not be equal to 0. So our A is 3 and our B is 12. So this will be our A, this will be our B, and this one is the B, and this also is the C. So then A divide C. So it's just a theorem. So we're going to prove. Now here is our proof. So we're going to prove that it exists. So let me show it to you. Proved. So we will write it in the form A divides B, B divides C, then A divides C. Now B is equal to AD, B is equal to AD. We're just doing the same thing as what we did earlier in the case that R is equal to 0. Remember that one? Let me write it again for you. Remember the case that R is equal to 0? Then the resulted equation was B and Q because there are no longer R because the value of R is 0. So if you still recall, then it is B divides A. So we're writing it this way. So B is equal to A in such a way that D here is any integer. We also have C as equal to B. And in this case, C and B and E is any integer, any positive integer. Now here it is. So C is equal to B. So C is equal to B. Then the C, here I see it. C is equal, then put the value of our B. What's the value of our B? That is AD. And input E. Now, the value of our C becomes equal to A multiplied to D and E. So D and E D and E here. So D and E here. The D and E here are just integer. So in this case, so we now have, in this case, we now have A divides C. Did you get the point? We're just giving the proof. We're just proving the theorem is true. So much for that. Thank you for listening. Take note the wheel ordering principle. Any non-empty set of a positive integer contains a smaller member. Remember also the division algorithm. A is equal to BQ plus R, wherein RQ is the quotient, R is the remainder. And consider as well that R is always greater than or equal to 0, but always less than to the B. If the case is, if the case is, if R is greater than B, then it is not divisible. So take note that one. And for the theorem that we have, take note that if A divides B, then B divides C, then A divides C. So take note. And let me clear all the terms here. And thank you so much for listening. And for the next topic will be the greatest common divisor, its definition, its theorem, and example, and a lot more examples. Thank you so much for listening.